identifying redox reactions. You can use oxidation number to identify these redox reactions by observing the transfer of any electrons via oxidation or reduction. Let's have a look at this question here. Which of the following below are redox? Okay, so we're just looking at one example right now, and we have to identify if it's a disproportionation reaction, or if there's any redox going on, or if it's neither. Well, as you can see, we are missing some oxidation numbers there, and over there, so let's fill it in. Okay, so what number does this have to be? Okay, so we got 1 phosphorus times what number will give us that 3, okay, to minus 3 and give us that net 0, okay? Well, it obviously has to be a 3, so we're putting a 3 up over there. How about this one over here? Well, we have 1 phosphorus times what number will give us that 3 in the middle, so that this whole thing can sum up and give us that 0. Obviously a 3, okay, so 1 times 3 will give us that 3, so that's the oxidation number there. How about this one over here? Well, we have 1 hydrogen times what number times 3 will give us that 3 there on the bottom, so that it can sum up to give us that net charge of 0 again. Well, this obviously has to be a 1, because 1 times 1 will give you 1, times 3 will give us that 3. Hence why we have all of our oxidation numbers here. So now let's get our like terms, okay? So we have our phosphorus over to this phosphorus over here. Oxidation number of 3, oxidation number of 3, so no transfer of electrons. Nothing happened. How about this chlorine all the way over to this chlorine? It's a -1 and this is a -1, so nothing happens there. No transfer either. How about this hydrogen to this hydrogen here? Oxidation number of 1 to a 1, nothing's changed. Or this hydrogen to this hydrogen here, 1 to a 1, nothing's changed, okay? How about this oxygen, okay? -2 all the way to here, -2, nothing's changed. Okay, so therefore there is no transfer of any of these electrons. Therefore there is no redox. Let's look at this question over here. How do the oxidation numbers differ from numbers that are used to indicate charge? Well, oxidation numbers are usually the same number as the charge, okay, the atom would have, if it were completely held by the largest electronegative atom. If you want to know more about electronegativity, see the video link in the description where I go into in-depth explanation about this, okay? But how do we label it? Well, if you have a number, let's say a +1, okay, a 1 charge, we put the plus in front of that number. However, for charges, we do the opposite, okay? The symbol goes after the number that you're kind of used to seeing on your periodic table in your junior grades, okay? So charges represent the amount of electrons it wants to take or give away to become stable, okay? And again, these are the two different ways that we represent it, okay? So these are the two green questions of the day. This is the first one, okay, and this here's the second one. Please pause the video, try these on your own, and I'll be giving you the answer shortly. This is the answer to the first question, and this is the answer to the second question.